So, I think we might want to cancel the launch. The rocket won't be able to leave the atmosphere.
What are you talking about, intern?
I did the math, and the answer is wrong. The rocket won't even reach the escape velocity.
Nonsense. Here, let me explain you the correct equation. Very well. Let us first write down the formulas we are using. A is equals to acceleration. M is equals to mass. F is equals to force. G is equals to gravity. R is equals to distance. And F is equals to mass times acceleration. The force formula is F equals to mass times acceleration. I'm going to call it MA. While the gravity formula is F equals to G times M1 M2 over R square. Alright, since both of them are force, we can now compare them and get G times M1 M2 over R square equals to MA. After you remove one of the M's, you will now get A equals to G times M over R square. Or there is another way, which is A equals to K times 1 over R square. If R is equals to the radius of the Earth, then A equals to negative G. Negative G equals to K times 1 over R square. Then K equals to negative G times R square. Alright, now we have A equals to negative G, and that's because we're fighting against the gravity in order to escape the velocity. Also, A equals to dV over dt times dr over dr equals to dV over dr times dr over dt equals to dV over dt times V. Then K times 1 over R square equals to V times dV over dr. Now we have to integral V times dV equals to K integral 1 over R square times dr. After that, it's V square over 2 equals to R power to the negative 1 over negative 1 times K plus C. Then our result will be V square over 2 equals negative 1 over R open parenthesis negative G R square close parenthesis. Alright then, let us derivate the function. We will get 1 over 2 V square equals G uppercase R square over lowercase r plus C. That will be our first equation. Our second equation will be 1 over 2 V square equals G uppercase R square over uppercase R plus C. We will then simplify our second equation and get C equals 1 over 2 V square base of 0 minus G uppercase R. The second equation, we will then insert it into the first equation and get 1 over 2 V square equals G uppercase R square over lowercase r plus 1 over 2 V square base of 0 minus G uppercase R. The result will be V open parenthesis R close parenthesis equals in a square root 2 G uppercase R square over lowercase r plus V square base of 0 minus 2 G uppercase R. Now you see, the following equation will now be 1 over 2 V square base of 0 minus G uppercase R bigger than 0. Why? It's because the rocket is going up to the sky. That's subtle. Since we're running out of time, let's just put these numbers that have been supplied in the internet. The Earth's gravity is equals to 9.81 meters per second, and the radius of the Earth is 6,371,000 kilometers. Alright then, let us insert these numbers into the equation, and we will get v base of 0 bigger than in a square root 2 times 9.81 times 6,371,000, and you will get 11,180.2961 meters per second. Factoring the weight of the rocket and the amount of fuel, this rocket will now be able to escape the atmosphere of the Earth.
Oh, now I understand how to use differentiation to apply to a real world problem. But, sir, why did you launch the rocket?
Well, my apprentice, to prove a point, of course.
Um, okay,
10,
this
9,
this
8,
is awkward.
7,
But,
6,
um,
5,
sir,
4, 3,
apparently the
2,
rocket wasn't
1.
even finished.